Hello, and a big welcome back to all of my subscribers. And if you're not a subscriber, why not? I'm back to my 68K project today, and I just wanted to say that this is not a tutorial. I'm not teaching anybody how to build one of these. This is just me sort of documenting my experience as I go ahead and build this project and then write the software. So if you're looking for a tutorial, as this certainly isn't it, I'm not a good teacher. I'm just showing you what I did. I have made some changes to the plan. So before I show you what I've done so far with the hardware, let me show you what I've done with the plan. As you can see here, I have added in a couple of 74HC 245 ends. Now these let me basically switch output, and I can connect these directly to the data pins on the CPU, and through these chips on the A side and the B side into some GPIO pins. So I've added 16 GPIO pins plus the 4 other additional pins, 2 for power and 2 for ground. One of the power rails will be 5 volts and the other one's 3.3. So I needed this in order to just mess around with GPIO, and because I could connect it directly to the data lines, it was fairly simple. But I did have to add in these level shifters for the power. And currently I'm waiting on a DC-DC buck converter so that I can do the conversion from 5 volts down to 3.3. And then I also plan to use those level shifters for the output of the SPI modules and for the I2C modules. Just about everything nowadays, like IC2, like on my real-time clock, is 3.3 volts. And so I've decided that I'm just going to bring everything to 3.3 volts. It won't cause a problem with the LCD display, I believe. I've looked at it. And my SD card is 3.3 anyway. So this all should work much better. And then now I just need to wait on the buck converter to come in. Now let me show you what I've done so far with the hardware. I have been busy working away and doing some very poor soldering on the back. I must say I've finally got in my wire wrap tool and some wire wrap, and in future I am definitely going to wire wrap in preference to any form of soldering whatsoever, only because I'm really bad at soldering. But basically what I've done is I've got the 6-pin header here, which will eventually be for the UART and serial port. At the moment it's just connected to the side, and then I've put some pins here that I can wire wrap onto. So very good. This is connection is for my mod VGA. Now I got the mod VGA card in, and that basically just sits on top of this Arduino, and then it gets VGA. I get keyboard input as well, but I needed this. Should I leave that in? There we go. So anyway, I got this adapter for the board, so now I can put that in. So now the other thing is here, I've also put in, you'll notice, 2 power rails for the board. Now I've got a power supply which I plan to use with this board. The other one, these are just wired to each other, so when I plug one in I get power on the other one, and I can use that to power the Arduino. which will be running the VGA and all of that good stuff. I started work on the GPIO pins, so I've got the GPIO pins that I'm going to have, and I'm wiring up the chips. These are the level shifters, they're already wired up. And then finally here I've got some LED lights. So what I've done is I have effectively already wired up all of the GPIO pins through the level shifter and into the chip. Now I just need to do the A side, which is from the CPU into the chip. But what I've done is I've wired up 16 pins here, which is the data pins, so that I've effectively got the data bus here, and then I'll do that back into the CPU and memory and all the other stuff. So I've got 16 pins, and then I've wired those into the LEDs so that I will be able to, when data is going back and forth, well in fact any time on the data bus, I will be able to see the LEDs flashing for the data, and that will help me initially, because I think my first test bootloader doesn't do anything but flash, well, make changes to the data lines so that these lights will flash. But that's all I've done so far. Not a lot. Well, it's taken a long time, but it's not a lot seems to have been done. But the GPIO that I added last is the thing that I've pretty much done first. And then the other things mainly are waiting for me to put these in. So I've got some wire wrap rails that have come in. This will be for the CPU eventually. So these wire wrap rails are quite long and very, very good for what I need. I've also ordered a few wire wrap sockets. These are 16-pin sockets, but I'll need some more. A lot more expensive than these. So in fact, the cheaper option really is to just buy these rails and then break off as much as you need and put the IC chip into it. So that is all there is to what I've done so far as hardware goes. Now, I do have more software. So I've written a hopefully fairly comprehensive README file on my GitHub site, which shows how to do all of this. I have managed to get this working in the QEMU M68K emulator. It can't do a lot of the stuff because it's memory mapped IO, so it's not going to be able to do a lot of the stuff, but it can certainly do the memory. And I have been working on enhancing all of this software. So I have been working on my bootloader, obviously, because that's the thing I need first. And just trying to make sure that it runs properly. I still need to add in a lot of the fails. I've done some memory tests. Once I get this working, I'll do more. But yeah, for the bootloader, that's it. But I have been working on things like interrupts and a vector table for it, and then I've just got some placeholder in there for a lot of the functions that I need to build out. I've been working on the SPI interface for the transfers, and mainly at the moment I've been focused on the UART, and that's because I should be able to see all of this because I can put the UART memory address for a QEMU in, and then the real hardware address when I build it later. So I've got a in my make file I can pick QEMU, and so I'm focusing on this because this is one of the things that I would be able to test in the emulator, whereas the mod VGA and some of the other hardware, I cannot test any of that in the emulator without actually rewriting the emulator, and I don't want to spend time rewriting the emulator. I want to work on my project. So I'm just doing as much as I can inside of the emulator, but in the main that is just going to be UART and memory checks mainly. I can do some interrupt checking, but that's pretty much it. Later on, so for example, I have looked at doing the FAT32 with the SD card. So there's a significant amount of work gone into that. But like I say, there's not a lot I can do until I get the actual hardware to test on. So that's where I'm at the moment. So a bit of hardware and a bit of software still working. That's it from me today. Thank you very much for watching. If you like these sort of things, please like and subscribe and all that good stuff. And please rewatch all my old videos. There's a lot of assembly language stuff for RISC processors and some of the older assembly languages. Also human languages if you're into that sort of thing as well. So yeah, please watch the rest of my channel. That really helps me out. And thanks for now. Bye.